All right, this is video number 3, the Unit 3 Midterm Remediation. Let's take a look at number 1. So, Laura wants to evaluate the negative square root of negative 16 and writes out the following work. She says that this equals 4. Is the working out correct? I'm going to say no, and let's do the work to show you why it's no. So really, when we're looking at this is the same as negative 1 times radical negative 1 times radical 16. Okay, well that's just the same as negative 1 times, and we learned that the square root of negative 1 is just I, and then the square root of 16 is 4. So that means our answer is negative 4i. So now, if we look at part B, the correct answer is clearly A. All right, let's take a look at number 2. Simplify 4 times I to the 10th. So another way we can write this is 4 times I squared, all of this to the 5th. So this equals 4 times negative 1 to the 5th. And then the rule with odd exponents on negative numbers is that the number to that exponent is also negative. So this is 4 times negative 1, so this is negative 4. Cool beans. Let's take a look at number 3. For number 3, we're asked to evaluate 3 plus 6i plus 7 plus 3i. And the first step we could do, we look to see if there's any distribution we need to do, any multiplication. There isn't, so we can drop the parentheses and we can just do addition of like terms. So here we see 3 is a real number, 7 is a real number, 6i is imaginary, 3i is imaginary. So we combine our real numbers. 3 plus 7 is 10, and then 6i plus 3i is 9i. And that's our answer to number 3. Now let's take a look at number 4. Number 4, we're just distributing this 7i and then combining like terms. So let's distribute. We get a 21i minus 14i squared. We know that I squared is negative 1, so we have 21i minus 14 times negative 1. So 14 plus 21i. I apologize, I'm missing a 1 there. That's our answer to number 4. Number 5, find the value of this. So we are looking at complex conjugates, and I know this was a topic that some of you students wanted to see when I asked in class. So we have a problem. And the problem looks like 2 plus 2i, 2 minus I, and we want to multiply this by the conjugate of this, which essentially we're just changing the sign in the middle. And to make sure we're not changing the problem, we have to make sure it's that over that, because that's the same as multiplying by 1. Therefore, it doesn't change the problem. So now we have 2 plus 2i in parentheses times 2 plus I over 2 minus I times 2 plus I. So we distribute, and we get a 4 plus 2i. Now I'm running out of space. Hold on. Okay. 4 plus 2i plus 4i plus 2i squared all over the product of 2 minus I times 2 plus I. So we have 2 times 2, 4. Then we have a plus 2i. And then next we'll have a minus 2i. And then finally we'll have a minus I times a positive I. Okay? And then we combine like terms. Note that this I squared really turns into negative 1. So we have negative 2 plus 4, that's 2, plus 6i all over These cancel. So we have 4 plus 1 because negative I times I is equal to negative 1 times negative 1 is 1. So we have 4 plus 1 all over 5. And then we simplify 2/5 plus 6 over 5 times I. That's our answer for this one. We're on to problem number 6. And I'm going to add a page here, just because this one looks a little longer. So we have 5 minus 7i, 8 plus 8i, and we're going to distribute. We have 5 times 8, 40. Then we have 5 times 8i, 40i. Then we have 7 times 8. That would be minus 56i. Then we have minus 7 times plus minus 7i times plus 8i. That gives us minus 56i squared. Okay, remember I squared is the same as negative 1, so that's the same as negative 56 times negative 1. So combining like terms, 40 minus 56, negative 16i, and then 40 plus 56 is 96. So this is our answer. Now, number 7, this asks us to consider this equation and to find the discriminant. Well, first we want to get this x minus 1 onto this side. So we subtract an x and add a 1. So we have 2x squared minus 2x minus x plus 1, which is the same as 2x squared minus 3x plus 1 equals 0. And then if we remember, our discriminant is negative b plus or minus, sorry, I got ahead of myself. Our discriminant is b squared minus 4 times a times c. So we look here and we see that b is negative 3. So we have negative 3 squared minus 4 times a is 2, c is 1. So our discriminant is 9 minus 8, which is 1. So what can we say about this number? Well, this is a positive number. And so when we think about how many solutions this equation will have, we know that b squared minus 4ac goes under a radical. So if it's a positive number not equal to 0, we're going to have 2 real solutions. If it was a negative number per se, if it was negative 1, we're going to have imaginary solutions because we're going to have an I. And then if it were 0, we have opposite b plus or minus the square root of 0. Well, that's just 0. So we're just going to have opposite b over 2a, just for future reference for questions like that. Okay, now we're going to solve this equation, which we're going to get to use our friend the quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So we see our b is 2 minus 2 plus or minus radical 2 squared minus 4, and then a is 1, c is 5, all over 2 times a, but a is 1, so just over 2. So this is the same as negative 2 plus or minus 4 minus 20 all over 2. Okay, well, 4 minus 20 is negative 16, so this is the same as negative 2 plus or minus the square root of negative 16 all over 2. And we solved what the square root of negative 16 is, right? We said that this was 4i. So our answer is negative 2 plus or minus 4i all over 2. And then it wants this in the form of a plus b times I. So we divide out the 2 and we get negative 1 plus or minus 2i. That's our answer for number 8. Okay, number 9. We want to determine the discriminant, and the discriminant is b squared minus 4ac. So the discriminant is negative 6 squared minus 4 times 7, What's 4 times 4 times 7? That's 16 times 7. We can do some quick multiplication. 6 times 7 is 42 plus 70. This will give us 112. So we have 36 minus 112, which that will give us 36 minus 112 will give us negative 76. And that's our discriminant. So how many real solutions does this have? I told you for problem 7 that a negative number gives us 2 imaginary solutions. So we won't have any real solutions. So B is the correct answer. All right, number 10. Solve, again, quadratic formula. X equals opposite B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so our B is 10. So we have opposite 10 plus or minus, what's 10 squared? 100 minus 4 times A is 1 and C is 28. This is all over 2 because A is 1. So let's do some quick math. 28 times 4 is going to be 32 plus 80. Again, 112. Okay, so we're going to have negative 10 plus or minus 100 minus 112 all over 2. Well, 100 minus 112, that's going to be a negative 12 all over 2. And then, well, negative 12, radical negative 12 is the same as radical negative 1 times radical 12. So that's the same as radical 12i. And then we could do some prime factorization of the number 12. 2, 6, 2, 3, 2 2's, and a 3. So radical 12 is equal to 2 radical 3. Therefore, we have negative 10 plus or minus 2 radical 3i all over 2. Then we divide out the 2 for each. So we have negative 5 plus or minus radical 3i is our answer. Okay, number 11, we're getting close to the end here. So we want to plot negative 3 plus 2i on the diagram, the complex plane. So we look at our real axis and we know that our value is negative 3. So we count 3 to the left. 1, 2, 3. Oops, sorry. 1, 2, 3. And then we go 2 up on the imaginary axis. So 1, 2. Our point is right here. All right. Final question. What is the complex number represented by the point on the diagram? So we see on the imaginary axis, we go 1, 2, 3, 4, 5, 6, right? Okay. So we know we're getting a plus 6i. And then our real number, we go 1, 2, 3, 4, 5. And we see that it lines up with 5. And that's a positive 5. So we get 5 plus 6i. Hope this was helpful for all of you. Thanks for watching. And I hope you have a great